looking at high school algebra progression. We'll start with seeing structure and expressions in elementary. In elementary, they'll be learning arithmetic expressions that involve addition, subtraction, multiplication, and division. Here we have two groups. P has 3 and Q has 4. They'll be able to recognize that one group is larger than another. So here, Q would be larger than P. As we move down here, they'll be learning the expressions Q plus P. They will be able to recognize that 4 plus 3 is 7. They will also be able to see that 2P is the same as P plus P. So here, 3 plus 3 equals 6. They will then be able to compare the two groups that 7 is larger than 6. This is the basics of elementary structure and expressions. As they get into later elementary, they'll use PEMDAS and fractions. They will get into more difficult expressions that will involve an expression where the subtraction is all on the top, so 4 minus 3, and then they divide by 2. As we're over here, they see Q by itself, and then P divided by 2.
Alright, so looking at middle school, we're going to look and see how they're using recognizing expressions such as x minus 1 that they've learned to recognize in elementary school and apply it to a little bit more complicated problem, and we're going to start tying in this little thing up here called an exponent and looking at exponentiation. So we're going to use a problem 5 plus, in parentheses, x minus 1 squared, and we're going to dissect it a little bit here and look at some different things they're going to know in middle school. So they have x minus 1, and that's what they're going to recognize as an expression which they've learned to identify in elementary school. Now, the biggest thing in middle school is they need to identify minimum values for these types of functions or expressions. And we're going to find that the minimum value is 5 when x equals 1 by looking at two things. First thing is this right here is called our squared term, and that's what students are going to start learning about in middle school. And they learn that this squared term is going to be equal to or greater than 0. And that is because any term that we plug into here and square it will be greater than or equal to 0. So our smallest number we're going to have in here is 0. Then looking at the second way, if we plug in x equals 1 and make this 0, 0 squared is 0 again. So then we have 5 plus 0, as seen here, that's 5. Therefore, we have a minimum value of 5 when x equals 1. And students would recognize this and be able to do this because they know that they have a constant 5, they're summing this entire thing because there's an addition sign, and they're finding the value of this expression in their squared term. Then, we'll move on to rearrangement and manipulation in high school, and we're going to tie in all the aspects that they've learned in elementary and middle school in high school. And we're going to use this problem right here to show that. So we have 2n plus 1 times n plus 1 all over 6. So first off, students can recognize the different expressions, the basic expressions that they would have learned in elementary school. And then they're looking at a little bit more complex one that they would have learned in later elementary. And then we're going to tie in some of these exponents that we just learned about in middle school as well. And so the whole goal here in high school is for them to be able to start seeing how they can rearrange and manipulate problems to be in a simplest form for that problem that they're doing. And so not every problem has a simplest form. They're all different. It's based on the situation. And so for here, we can see that students might want to FOIL. So here we would distribute our n to our first section of the expression, and we'd get 2n squared plus n. Then we'd have n plus 1 times this first part, and then we would end up with 2n cubed plus 2n squared plus n squared plus n. Now we need to combine our like terms, which is something they start to remember and learn how to do in high school. And once we've combined them, we have 2n cubed plus 3n squared plus n, and it's all divided by 6. Well, then we're going to bring in some of our basic elementary math here with division, simplify, and realize that we are splitting our fraction. We took one big fraction and split it into 3 smaller ones. and this is something students also learn in middle school. And we now have a resulting expression of 1/3 n cubed plus 1/2 n squared plus 1/6 n. But the important thing is to look and see how this expression is still the same expression here, just rearranged and manipulated in a different fashion. They're still the same. That is a big concept that they grasp, and it's all, the whole goal of this is for them to see that the structure of this may look different, but in the end, they're still equivalent. And that's the biggest thing that they need to learn in high school when they're looking at structures and expressions. Now that we've looked at seeing structures and expressions, we're going to look at the arithmetic with polynomials and rational expressions, and we're going to look at how the foundation is laid in elementary and middle grades, which is going to allow us to do our work in high school with these polynomials. And so in elementary school, they start with basic math computations such as 8 plus 3 equals 11, which they can represent with 10 frames, or they have 3 divided by 4, which equals 0.75. Now these can be seen as calculations with an answer such as 8 plus 3 with the answer being 11, or 3 divided by 4 with the answer being 0.75, or they can be seen as a representation, as this 11 is a representation of 8 plus 3, and 0.75 is the decimal of a fraction, just another way of seeing it. Then we move to middle school. We take this foundation from elementary school, and we went from whole numbers in elementary school to now we're looking at integers, which involve all of our negative numbers. And we're going to look at how they still work with the number line, how it grows in both directions now, and how this whole thing is one big unified system, also known as the number system.
Now we're moving into high school. They'll be looking at x minus 1 to see that x is introduced as a number. It is known as an unknown number and stands for the missing number. As they learn this, they move into polynomial expressions like we have here. We have 3 different polynomial expressions that we'll be looking at, and they're all equivalent to one another. We'll find this out by solving the polynomial expression. We'll take 3 and plug into x wherever there is an x. So here we have 3 squared minus 2 times 3 minus 3, which gives us 9 minus 6 minus 3, or 9 minus 9, which gives an output of 0. Here is our function machine, and it's a representation of putting in a 3 and outputting a 0, which is what we just did in this polynomial expression. Next, we'll look at x plus 1 times x minus 3. We take the same number and plug in where x is. 3 plus 1 times 3 minus 3 gives us 4 times 0, which gives an output of 0. And the same thing happens as we put in 3 and it gives an output of 0. The last one that we'll look at is x minus 1 squared minus 4. If we plug in 3 where x is, we get 3 minus 1, which is 2, squared, minus 4, which is 4 minus 4, with an output of 0. So now we have seen that all 3 of these expressions with an input of 3 gives an output of 0. Now as they recognize polynomial expressions, we'll move into long division. Here we have x plus 2 going into x squared plus 3x plus 2. I'll use these representations to break down the polynomial expression. This flat will represent x squared, while these sticks represent 3x. And these single counters represent 2. Now putting it all together, we have x squared plus 3x plus 2. And we always want to form a rectangle. Now we can see that x plus 2 going into x squared plus 3x plus 2 gives us x plus 1. And we see that that is our answer up here. We can also see that x plus 2 times x plus 1 gives us x squared plus 3x plus 2.
Alright, so now that we've looked at arithmetic with polynomials and rational expressions, we're going to look at creating equations. And in elementary school, they start out with just really basic, simple things that we may not really see as equations, but to an elementary schooler, they really are, such as 3 plus 2, or 32, doing 3 plus 2 on your fingers. Just very simple, basic things, but they're very simple equations still in the grand scheme of things, which help make this connection later on in high school. Then in middle school, we're going to start looking mainly with linear equations, such as 4 minus x equals 6, and then they'll learn how to start solving for these very basic linear equations, as seen here by saying subtract 4 from both sides, which leaves you with 2 on this side with a negative x on the other. Then divide out that understood negative 1, leaving you with x equals negative 2. So we're going to start looking at stuff like that, and that's one of the things that they start doing in middle school is just working with those linear equations. Then moving into high school, this is where they really start getting that whole concept of creating equations and pulling it all together and tying in all these things that we've talked about so far, and starting to really see the use of them. And so we learn this through the modeling cycle, which we start with a problem, we formulate an idea, we figure something out, then we compute based off of what we came up with when we formulated, and then we're going to interpret. We're going to say, okay, what does that mean? And then from the interpreting stage, we got to validate. If we can't validate what we did and we can't prove it, then we have to go back to formulate and start over. That's why there's a little loop right here. But if we can validate what we did and show that it is true, then we can report or give our answer. So this allows us to start looking into different equations, starting to model with equations. But one of the big things that we have to do is introduce the idea of parameters in high school. So we all know the formula y equals mx plus b. Well, in this case, m and b are the parameters of this equation. So when we have y equals mx plus b, we're going to use y equals 2x plus 3. So when I plug in a value for x and a value for y, I get value of x is 1, 2, and 5. We're going to get a value for y of 5, 7, and 13 based off of this equation right here. So we'll do it again with another one, y equals 3x plus 4. Again, we have x is 1, 2, and 5, the same as this one over here. And we get 7, 10, and 19. What changes this is we have the same x values. So x is in our varying number or whatever. It is the m and b, which are parameters. They're what make the difference with this type of equation and these types of functions. And so this is a big concept from the graphs, is that changing this m and b, or these parameters, they are what control our outcome, and we can see that on the graph here, and we can see that how changing m and b graphically, how it messes with the y output. How that's what, it's not the x value, it's the m and b, what they change is what affects our y. So knowing all this, we can start modeling with equations. So we have a problem here, and it says Selena bought a shirt on sale that was 20% less than the original price. The original price was $5 more than the sale price. What was the original price? Explain or show your work. So students would be able to come down and deduce a equation such as this one right here, which is p minus 0.2 p equals p minus 5. P would stand for the original price, or the original sale price, and then they already know, based off of all their math in the past couple of years in elementary and middle school, we have a percentage. We're going to convert that percentage to a decimal. And then over here, we have p minus 5, which is representing the $5 less than up here, because the original price was $5 more. So we've got that right here. So now they're going to set this up. And now that they've modeled this situation with an equation, and we remember over here at our modeling cycle, we formulated, now we've got to compute. So we're going to compute this. We're going to look at it. We're going to start solving. Well, when we solve, we subtract p from both sides. We get negative 0.02p equals negative 5. Divide out the 0.02. And we get p equals 25. Then we're going to come over here and we're going to check it. So now we've computed. We're going to interpret. We're like, okay, well, that might sound pretty good. We're going to check it. Checking is kind of our interpreting, validating stage, kind of in one. And so we're going to, right here, we're going to check. So we get 25 minus 0.25 times 25 equals 25 minus 5. Solve it out. We get 20 equals 20. There we go. So we can report that 20 is our answer. So they've modeled this situation, this real life application problem with an equation, and this is the whole concept that we wanted them to get to in high school. So we're using this modeling cycle, which is developed over time from elementary, middle, to allow us to get our students to be able to model with equations in a real life application. All right, so now that we've done creating equations, modeling with these equations, and everything, we need to look at the reasoning behind them. So the reasoning with equations and inequalities, we're going to look at the main meat of the whole thing, which is our reasoning, our process, how we got there, why we did what we did. So we're going to look at this first off with equations in one variable. So we have x squared equals 4. So we can see here that we subtracted 4 from both sides. So we have x squared minus 4 equals 0. And we took the x squared minus 4, broke it into 2 parts, and we have x minus 2 times x plus 2 equals 0. Solve for x, and we said x equals 2 and negative 2. But the big thing is why? Why did we do this? What are we saying here? So what we see here is the short mathematical shorthand of this long explanation. So we have, if x is a number and it is squared, and its square is 4, then x squared minus 4 equals 0. Since x squared minus 4 equals 0, it equals x minus 2 times x plus 2, which is equal to 0. So, in that case, x minus 2 equal to 0, then x must be 2. But if x plus 2 equals 0, then x must be negative 2. That's the reasoning that this mathematical shorthand represents. That is what we're showing here, and that's what students need to understand.
Now we're going to look at system of equations to see the process of reasoning. And here are two equations. Negative 4x plus 3y equals negative 2, and y equals x minus 1. We're going to use substitution to reason through this. We're going to take this equation, since it's set equal to one variable, and we're going to plug in x minus 1 where y is. Rather, we're going to substitute. So we're going to take x minus 1 and substitute into y. And we can see here that our x minus 1 is substituted in. Now that we can see that, we're going to solve for x. And here we have negative 4x plus 3 times x minus 1 equals negative 2. Negative 4x plus 3x minus 3 equals negative 2. Then we have negative x minus 3 equals negative 2. Negative x equals 1. Our understood negative 1 needs to be divided out so that x equals negative 1. We'll take our negative 1 and plug it back into our original equation. Y equals negative 1 minus 1. Y equals negative 2. We are then given our points negative 1, negative 2. You can also look at graphs to reason through as well. We have a line here that's f of x and another line that's g of x. Here they intersect to give us points x and y.